All right. Hello. Welcome to the stream. Can everybody hear me? Let me know. Let me know. Hello. Yeah, we're starting with this image by Beeple. Just absolutely terrifying. Can you hear me, everybody? I hear you. Sweet. All right. Welcome, welcome. Let me know where you're watching from while we just take in what is the majesty of this image. All right. What's up from Brazil, Thailand? Cairo, South Africa, Norway. Awesome. Welcome. We got a lot of people from all over the world. I love that. It's so cool. Romania. Awesome. Chrome. Yusuf from Belgium. Luca from New York City. George from Philly. Cornell from Hungary. Awesome. Fox on the Run, Germany. Dang, we got everybody from all over. Yeah, this image is everything. All right, Portland, Gareth. What's up, Gareth? India, AI Ida Run. Hopefully I'm pronouncing that right. Yeah, so we had some good memes coming out of yesterday. I did a stream yesterday about all the news with Dario and Elon working together. That was a lot of fun. We're publishing a video about that right after the live stream is done, so be sure to check that out. If you're here, like the stream, share the stream. Really appreciate it. From PA, Chris. Hello. Yeah, man. Great memes from yesterday. Not only do we have that fantastic image, but we have potentially some of the coolest text messages I've ever seen. Directionally very bad, Mira Murati. Did everybody see this already? This is, so for those of you, for context, this is the text messages going back and forth between Sam Altman and Mira Murati during that very brief couple day period in which Sam was getting fired from OpenAI. Actually, this was really like the hour or two leading up to it. Mr. T. Morton will need some thoughts on sub-Q also. There's just not much there. Bombastic business, first time catching your live stream, welcome. Yeah, so look, imagine, like, try to put yourself in Sam's shoes right now. You're sitting outside the boardroom. You have Mira Murati and the rest of the board who just fired you. You're texting, you're saying, what's going on? What's going on? You have Satya Nadella texting you saying, what's going on? He's also texting the board, what's going on? And you're sitting out there furiously texting with Mira Murati. Can you indicate directionally good or bad? Satya and others anxious. Directionally very bad. Okay. Like, I've been there. It is the most relatable text message I've ever seen. You know, you're like texting somebody, you know, maybe there's some bad news coming, and then you get it. Directionally very bad. Okay. What are you supposed to do other than say, okay? All right, we got a couple other things to cover, and then I'm going to bring on a very special guest. We have Richmond Alake from Oracle, just an absolute master of agents and memory. And we're going to be talking about agent memory. There's a lot to talk about. We're going to get his thoughts on Anthropic's dream feature, and then he's going to tell us how he thinks about agent memory, how he gets the most out of it, how you can get the most out of it. It's going to get a little technical. Ask questions in chat. That's what we're here for. That's what Richmond's here for. So be sure to do that. Okay, what happened? Mr. BCA? Yeah, okay, so just again, imagine, can you wrap up soon? Lots of pressure from Microsoft for an update. Sam, this is very bad. I swear I've had these same text messages with people in the past. Errol from London, what's up? He's like, can I come in? Just imagine he's sitting out there alone, like hunched over a bench. It's just wild. It's just wild to picture. You can really like put yourself in his mindset. They don't want you to. And I think Sam actually like handled it pretty well. I don't know if he knew that these text messages would become public one day, but he sure like he handled it with grace. What do you want? What do you want to make it better? I'm still willing to just walk away if that helps. If they are ramped up for crazy lawsuits against me, then I'm not sure what. And yeah, so he's just going back and forth. Okay, so you might have seen this right now. And then we're going to cover this after Richmond comes on, but OpenAI just released GPT-Realtime-2, so really voice is getting a big upgrade. We'll cover this right after this was just released. I think it's time. Let's bring in our guest. Richmond, how you feeling? You ready to come in? Give me a thumbs up. Yeah, buddy. All right. So let me bring Richmond on. Oh, that didn't work. Let's try that again. All right. Richmond, welcome. I just have to fix my camera.
Nice. Well, thanks for having me, Matt. And
Hey, Richmond.
you can hear me all right, right?
I can hear you. Yeah. I just can't see myself. Let's see. Nope. Sorry. Give me one moment. This is all because I switched video capture cards. There we go. All right. So we're going to have to do it this way for now. Welcome, Richmond. Welcome. So Richmond is developer experience at Oracle. Is that right?
Yeah. Helping out with the developer experience at Oracle. The mission is to reach AI developers.
Yeah. Well, very cool. I first saw you, I think it was a while ago, maybe 6-9 months ago. And I was watching a video that you had made about agent memory, and I was just blown away by your depth of knowledge and obviously like technical prowess as well, but just how well you explained and simply you explained these like very technical topics. So we've been trying to get together, and I hit you up earlier in the week, and I was like, hey, you want to come on stream? And you were just like, yeah, man, let's do it. So really appreciate it. Strong echo. Got it. Okay, working on it. Echo. Yep. I think. Are you wearing headphones, Richmond? No, you're not. That might help. I see the echo might be on my end as well. I'll throw my headphones on. Look, we're figuring it out live. That's what we do.
Exactly.
All right. Give us a moment. We're figuring this out.
All right. So is there still an echo?
Yeah, I don't hear any. Chat, do you hear echo now? I hear you in my earphones.
I hear you in my
Hardware is hard, Mr. T. Morton. Hardware is hard. AGI will not save us. It's good. There we go. Sweet.
All right. That's good.
All right, we're in. So, yeah, thanks, man. I appreciate you joining the stream.
For sure. Like you said, we were meant to do this a while ago, but I'm glad we're here now.
Yeah, and I realize you want to share your screen today, and I need to figure out how to let you do that. That's a whole new thing.
Well, I see a
Let's,
share screen button on my side,
yeah.
so
All right. Well,
maybe.
before we do that, since I already have mine sharing, I want to talk about the dream feature because you are the right person to give your thoughts on it.
Yeah,
Right. Is it not here, Claude? Come on. There we go. Dreaming. Okay, let me pull up the blog post and I'll just read a little bit about the dream feature. Marmar Labs, hey, what's going on? Let's manage cloud agents. All right, so today we're launching Dreaming in Claude Managed Agents as a research preview. Dreaming extends memory by reviewing past sessions to find patterns and help agents self-improve. I think just the name Dreaming it just makes it sound really, really cool. But Richmond, tell me like your initial thoughts. What do you think this feature actually is doing?
yeah,
And why would they do this?
yeah. So I haven't had a massive deep dive into this feature, but it sounds like the name Dreaming is actually good because one thing I find is creating human parallels with in the space of agent memory helps people understand what's going on. So dreaming humans, we dream as a way to sort of consolidate our memory. And I'm not a neuroscientist, so if there's any neuroscientists in the chat, you can put a better description of on why we dream. But the dreaming mechanism in humans is important for us to be able to remember information that we've experienced during the day and helps our actual brain, I guess, flush out of a sort of waste in a sense. But in the sense, right, in the technical sense, I think what they're doing is just consolidating memory, fixing, reinforcing some memory signals that they have stored, maybe during a session interaction that you're having with Claude itself, and also forgetting some of the previous information that might not be as useful. And what that will allow is next time you're using Claude, maybe after it's woken up or in a future session, you will start to realize it has better memory or can surface up information much quicker and it starts to learn some of your patterns. In fact, this is not new, right? I think a couple years ago, the letter MemGPT guys, the guys that wrote the MemGPT paper, Sarah and Charles, they released a paper called Sleep Time Compute,
Yep, here it is.
which you got a paper up, nice.
Yeah.
Which is the similar, it's kind of like the similar concept. And if there's anyone you want to be following in the space of agent memory, it would be these guys, right? These guys
Yeah.
are probably like a solid year ahead of the space. So they released Sleep Time Compute. What year was it? Does it say the year of the
Yeah,
paper?
this was just about 1 year ago,
Yeah.
actually. Yeah.
So exactly. So these guys are literally a year ahead. So they really put out some good stuff, and yeah. So I think that's what they're doing there. Just reconsolidating memory, solving conflicts, surfacing of patterns, so that the next time you interact with Claude, it will remember and surface up information much quicker.
Yeah, it's super interesting. I don't think I appreciated that they were actually over a year ahead of what the industry is doing. Yeah, I mean, if you haven't seen Letta, go check them out. Friends of the channel as well. Charles is awesome. Sarah's awesome. Um, it's like there's a few benefits. Let me actually switch back to this page. So I think there's a few benefits here. And Richmond, you tell me what you think. One
Mhm.
is, look, until literally yesterday, Anthropic has been compute constrained. And if there was a way to offer better quality responses with less tokens, they would take it. And I
Yeah.
actually think this is a way to do that because you're consolidating all of these memories, you're cleaning them up. The agent self improves in a way. The agent knows what you want more cleanly. And what does that mean?
Hmm.
That means that when you, during the day, ask it a question, it's going to be able to answer your question more precisely with fewer tokens. And so essentially, what they're doing is almost offloading some of the compute demand to non-peak hours overnight, right? They call it dreaming. The branding is as you said, like it's absolutely brilliant. So they offload some of that compute to non-peak hours during the middle of the night, And then all of a sudden, when you go to use it during peak hours, it's more effective with less tokens. Is that kind of your read as well?
Yeah, so yeah, that is my read, and it's all about operational cost, right? Even for them and also for us as the AI developers, reduction of operational costs is where the field is headed, and agent memory solves it. And I've been in the space for talking about agent memory for 3 years now, over 3 years, and it's just such an obvious problem to solve for every player in the AI stack. And I see some folks in your comment section mentioning hindsight. So hindsight is another key player in the agent memory space. It's a paper. They have a paper out, and it's built by Vectorize. And the CEO actually, we jumped on a call a few weeks ago, Chris. I jumped on a call with Chris, and we're speaking about agent memory, and we're cooking up some things with hindsight as well over on the Oracle AI database side. So we can definitely talk about a lot of things. But yeah, it's all about saving operational costs on the inference side, on the actual model performance side as well. And the human analogy helps people understand what we're actually doing. And it's not just Anthropic, right? OpenAI actually did something on memory this week as well, right? So they improved the UI where users can actually upvote or downvote particular information on memory that are used as sources to answer questions. So I think OpenAI is leaning more on the human feedback to actually improve. I call them memory units, which is the smallest atomic unit of information that an agent can actually use to remember. So you have this OpenAI using this human feedback of upvoting, downvoting, and correcting to improve memory itself for its users.
And where is this again? Where are you seeing this?
Yeah, I saw if you go on the OpenAI's tweet to X page, let me see if I can get it up. They just put this a few days ago, so let me see if I can get this.
ChatGPT?
Yeah, let's go.
Let's see.
Let's see. Okay,
ChatGPT Instant. Image 2.0.
I think it's on that thread with the ChatGPT instant, is it?
Okay, let's take a look.
Let's see. There we go.
Yeah, here we go. Better memory, more personalized. It's in here somewhere. Memory sources?
Yeah, memory sources, that's it.
Okay.
Talk.
I see. Right. Relevant, not memory, not relevant. Talk a little bit about what they're doing here, what we're seeing in the screenshot.
Yeah, so I don't know about the mechanisms, right? But what they're doing here is very simple. The information that you want to surface up, right? The information or memories that GPT is probably consolidating over interaction, and it's using them to answer questions in a moment. But there needs to be a way to sort of say, oh, this source you're using, this memory you're using is bad and don't use it again, or it's good, use it again. It's a reinforcing mechanism of memory for GPT or for the LLM itself, which is going to improve the experience and the personalization of GPT to the end user. But again, this is not new because we've seen this mechanism. I think 3 years back in a Stanford paper called Simulacra Generative Agents.
Yeah. Oh, I made a video
Yeah.
about that. Human simulacra. Yeah. Simulacra paper. That was so good.
So
Here, this one.
they
Junsun
nice,
Park.
nice.
Yep. Bam.
So
This
they
one
had
changed my life. I read this maybe a dozen times, Richmond. This was one of the most fascinating papers I ever read. Actually, one of the first papers I ever reviewed on the channel.
Oh wow. Yeah, it's such a good paper, and it's one of the paper when I met Andrew Ng for the first time, it's one of the first paper we both spoke about, right? This was over 3 years ago when I met him. We did a couple courses together, and we were just nerding out on this paper. And this paper has, I think, has all the foundation work that we see in a lot of memory implementation today, right? Including this forgetting mechanism.
Totally.
Or this mechanism, yeah. So it's a good paper. It's still relevant today. If you haven't read it, you should go read it. You're looking at, again, it's 3 years ago, or maybe 4 years ago now. I don't even know, but it's so relevant today.
Yeah, absolutely. Just imagine they drop. Okay, so look at the date, first of all. August 6th, 2023. Not too long after ChatGPT really blew up. And so what they did was they took 1,000 agents, gave them all personalities, gave them all memory, and dropped them in this little simulated town and allowed them to basically live life. And there was some really interesting emergent properties that came from it. Like, they would form relationships. And then I think one example, I mean, maybe it doesn't seem as mind-blowing today, but at the time it was. One agent, it was their birthday, so they invited their friend to their birthday party. Their friend invited another friend and asked if it was okay if they could bring another friend. Like, this is all like very emergent human-like behavior, which is so interesting.
Matt, and I have to agree with you, which is, it might sound not exciting today, but it was so exciting at the time. I was like, wow, obviously memory is where it's at. I would say this, right? This was, and the way I describe it to people today, this was Malt's book before Malt's book.
Yes. Oh, I didn't put that together. That's such a good call. Yes. Totally. Okay. So what do you, I think, like, we were talking right before we started the stream, and you had some thoughts as to, like, is human in the loop, kind of human grading, human as a judge, going to be persistent? Is it going to stick around? Because it just seems like that's probably the slow part of this entire process here.
Yeah, I do think, when in terms of agent memory, I do think the ideal is not to have this human feedback loop. You want it to be automatic. In the short term, we are going to need this feedback mechanism, especially for the frontier labs. They're probably going to use this feedback mechanism as a way to retrain some of the future model to handle memory better, right? So in the short term, we're probably going to see it. In the long term, it's going to go away, and it's probably going to go away very quickly. As in, I teach a lot of people about agent memory, and you can get some good performance without necessarily having human feedback in the system. But for a lot of, for OpenAI, where they're serving hundreds of millions of customers in a week, they can't afford to make, I guess, mistakes. As in, they did one previously, maybe last year, with the sycophancy. It's such a hard word to say, but I don't know if you remember when OpenAI had this minor blunder with their personality implementation within
They had to roll it back. Yeah, I remember that.
They had to roll it back. That's memory, right? That's a memory problem, right? The person. Sorry, go on.
No. Please continue.
Yeah, I was gonna say that's a memory problem, right? Because one thing I teach around agent memory, and I'm saying the word I teach a lot, but one of my latest courses with Andrew Ng on deep learning AI, and we touch on all of these things you're seeing in the space today. So you can go take the course, and you'll be clued as to. Is there a place I can share a link or something?
Yeah. Let's see. If you drop it in our chat, I'll have Brian drop it in the public chat. And then Richmond, as we're going through this, where can people find you? Where like, if they want to check you out on X, if they want to check you out other places, what's the right place?
Yeah, you can just Richmond Alake. My name is my handle on X, and you can find me on the same on LinkedIn. I'll put the links as well to be shared. So I've just shared the link with the actual course where we touch on everything memory, and I've put the links to my social media profile. But so memory is very important. It's easy to understand. That's the best thing about agent memory. When I say the word memory, my mom understands it, my grandma understands it, right? So it's easy to understand. It brings everyone together when we talk about what we're trying to do in the space of AI today. And we're seeing a lot of frontier labs actually solving this, but we're seeing a lot of solo developers solving memory as well. I think there's a level playing field in agent memory where you can have someone just build a solution and raise several millions and go to market, or you have frontier labs actually solving this live and trying to put something out there, but it's not solved. Memory is not solved.
Yeah. Okay. So I just dropped your X link. I'm also going to drop the deep learning course. Go check it out. I believe it's free, right?
Yeah, it's free.
Yeah, all free.
The deep learning is free.
Yep.
Yeah.
All right. I actually, Fox on the Run had a good question. I would love you to address this. So let me read it. Honest question. Isn't dreaming just admitting transformers can't hold state? So we bolt on a pass over logs and call it learning. When does the field move to substrates where memory and compute fuse? And I think this is a common critique of current large language model or current AI architecture. So I want to get your thoughts. Do you think that's true?
Yeah, that is definitely true. A lot of the solutions we see around agent memory today are not touching the actual model weights and parameters, right? We're not changing the internal states of this LLMs. It's more of it's bolt on, right?
Yeah.
That's true. And to be honest, and I would argue, and I'm still trying to figure this out, I would argue that that can be enough. I'm still trying to figure this out in real time. Is it enough? Will it get us to where we want to get to? We're yet to see. But one thing I would say is this is where you go into the field of continual learning, which is not a new field in computer science, by the way. Continual learning is an age-old field within computer science, but continual learning is where you probably want to be getting to, where you're looking at how can we change the internal state of a neural network to be able to represent maybe new information and do that continuously in a system that is meant to operate at real time, right?
Yeah.
But the addition to this is, yeah, it's continuous learning is what we're trying to solve. And Dario did a podcast with Duakesh. I don't know how long it was. I think it was this year.
It was a couple months ago. Yeah.
And he said, just with the in-context learning capabilities of this LLM, we can get to trillion or multiple trillion value in terms of economic value.
Yeah.
So his opinion was we don't need this continual learning paradigm to be able to realize this gains from this LLMs and usefulness. But again, in-context learning or actually changing the states within the model's parameters, I'm still trying to figure where it's going to, where things are going to lie. And I think I'm in the best place to figure this out. So I'm at Oracle, and Oracle, we're in the arena. We're experimenting with agent memory every single day. We talk about it. We put things out there in the frontier. We just released a package. Literally this last week that helps implement agent memory in most of the agents people are building. This is a Python package, but we're also exploring continual learning with some of the compute we have and some of the models we have on our infrastructure.
Yeah, and Richmond, you're going to share some things, and we'll get to that in a second. Yeah. But I want to comment on this because this is a really interesting topic. Is it like to reach AGI or to have that next like step function improvement in AI? Is it required to actually evolve the weights, meaning in real time actually change the weights? Continual learning, as you said. So it's interesting because like I think you're right, and obviously Dario is like he made the prediction we can get trillions of dollars in economic value simply by building a harness around it, allowing it to have memory, without ever changing the weights, static weights. I think that's probably it. And then if you think like, okay, if you just look at the weights itself, maybe that's just like the engine of a car, and you still need the car around it to get the horsepower to the road and drive somewhere, right? So like maybe the model weights are never going to be enough, and you needed the harness around it. You needed memory. You needed tools. I keep flip flopping too. I'm not sure. It just
Yeah.
seems like with all the progress that we've seen, especially around harness engineering in the last 6 months, we're going to be able to get tremendous value out of the current architecture of these models.
I I'm like you. I'm not sure. The only way I can be sure is just by being in the arena, Matt. So that is the only way I can be sure. So I'm learning and I'm teaching and I'm experimenting in real time. So I'm gonna be in the Bay Area next week, and I'm gonna be sitting down with a bunch of developers specifically on continual learning, what's working, what's not working, what the perspective of developers in the space of agent memory. So I can share a link, but it's more of a private event, so I don't want it to be oversubscribed.
Cool. Okay. One quick thing. So this is actually from Darit, LoRa based memory
Yeah.
first. This is actually something that I've seen. I read a few research papers where they were doing like um, real time LoRa, basically kind of modifying a part of the model to essentially update it in real time. Have you thought about this at all?
Yeah, I've thought about it before this current wave of LLMs, and so my background is in deep learning, machine learning, at the academic level. We used to have this thing called feature stores, right? Which was this. I don't know if you know what I'm talking about, but feature
Mm-mm.
stores in the traditional machine learning sense was this interim data layer where you can have your you could have this high signal information that you could use to fine tune machine learning models that were in production, right?
Yeah.
And this is we had this paradigm a few years ago. The reason why we're not seeing that today is LLMs are massive in terms of model weights and parameters, and you can't fine tune them in real time. And obviously, using LoRa can be a technique where you can actually get to that sort of reduction in latency and fine tuning these LLMs in production. I have seen it, and it's one of the directions that we're looking at experimenting. You if you follow me on LinkedIn or on Twitter, you follow Oracle Developer, you're gonna see something from us in a few months. Like I said, we're definitely cooking.
Okay. Richmond, I'm going to say sorry in advance. I'm going to try to make the screen share work in real time. Let's just see if it
Yeah.
works. Let's figure it out together. Go ahead and share your screen. Let's see what happens.
Excellent. So let me do
You,
this.
you would think I would be more prepared, but you would be wrong.
No, it's all good. Yeah, let's see this. So what
Okay,
can we
hold on.
see?
Okay. I think I got this.
Can you see the
Okay.
previous slide?
I got that. Let's see. Solo PFP. Oh, hold on. I'm working on it.
Nice.
Yeah, so I got this. Oh, there we go. All right, you're on screen. Let's see if I can get me on screen as well. There we are. Look at that.
Nice, nice.
All right, walk us
That's
through
it.
it, Richmond.
We don't need AGI. Let's go. So I'm just gonna share a bit. Whenever I talk to folks, I don't like to assume the knowledge they have. So I'm gonna say a few things that might be a bit basic, but that's just building up on our knowledge. Then I'll show you a couple of links. I'm gonna show you guys this Oracle Agent Memory that we released, and there was a blog post talking about how we actually perform on benchmarks like long mem eval and what the future looks like. I have a demo over here, an application. Then I also have a GitHub repository where the team over here, we literally work on this repository every single day, and we have a section dedicated to agent memory. So, and we have several notebooks that you can just get a deep dive and understand what this whole space is about. So
And
I'll share the
Richmond,
link.
zoom out,
Go on.
zoom out for a second. What is like? How should people be viewing this stuff? Is it like
Yes.
something they can use day to day? Is it just for kind of, hey, this is just how it works behind the scenes?
Yeah, so this is really behind the scenes, right? So in terms of this Oracle AI Developer Hub repo, this is behind the scenes. If you're a hands-on AI developer, you can go to this repo, you can look at notebooks that will touch on specific topics, or you can actually get full apps, right? So this application I'm demoing actually lives right here in this finance AI agent demo. So you can just get full apps. The team is building full apps in this repo. But if you're a developer and you don't want to concern yourself with all of the nuances with implementing memory, the team here, we released this package called Oracle Agent Memory just to solve it within. It's a Python implementation. We'll probably look at other languages to provide this in. So this is how you should look at. But I want to go into what agent memory is and take your audience to a state where they could just understand what's going to happen in this space within the next, let's say, 6 months. How does that sound?
Let's do it.
Let's do it. Let's go. So let's talk about the maturity of AI application over this last 3.5 years or so. We started off with LLM chatbots, right? ChatGPT came out onto the scene, and we had this incredible word compressor, which is the LLMs behind the chat interface, and you can ask it several questions. Then we found out that was nice for a few minutes, but if you want to get real value, you need to provide domain-specific data. So we quickly moved into the world of RAG-based application, which is Retrieval Augmented Generation, which is basically I'm giving a prompt to an LLM, but I'm going to supplement it with actual data that is going to help it answer better. This could be personalized data to me or information about context about the problem domain I'm trying to solve. But now today, we've moved away from RAG, right? We're still using RAG, but in a more evolved, enhanced version. Today, we're in this space of automation and autonomy. So automation, essentially, this is just LLM-driven workflows. And autonomy is you give an AI a bunch of tools and you tell it to go wild. Most people want autonomy, but what they need is automation, right? So a lot of the customers we work with, it's more automation, more workflows are automated. You understand step-by-step process of any sort of task you're doing, and you look for ways to automate it. And you have an LLM involved in the automation or involved in the processes to make some minor decisions, as opposed to. Sorry, I think you have a question.
No, I was just going to say for anybody in chat, if you have a question, if you want to ask Richmond anything, if you want any clarity on any of the things we're talking about, just drop questions and I'll bring them up on screen and I'll prompt you, Richmond, to try to answer them.
Exactly. Okay, thanks a lot. So automation autonomy is where we're at. I'll go a little bit quick. There's a lot going on the screen, but this is just showing retrieval augmented generation, right? Where we have this data ingestion process. There's an embedding model, which is able to convert data into this form that allows the things we're seeing around vector search or semantic search, right? We have this, you could pass in an image into an embedding model and you get this numerical representation over here.
This is a crazy
data.
graph.
It's it's crazy, but I actually do break it down for the sake of time. I can't, but I do break it down in the course. But one thing is you have this, you could have this data that you've extracted projected in different forms. You can have it in a JSON form, you can have it as some form of knowledge graph or a vector representation. And then you can store this in a database and then retrieve it and pass information into an LLM when you're conducting, when you're trying to answer questions from your user through the user query. So this is the main thing is this ingestion process, right? And then passing through an embedded model. I have seen some anti-patterns where people have a bunch of databases within the AI infrastructure for each of this representation. That is an anti-pattern because what I'm really focused on is reducing the cognitive load for both the agents and the developers. So I work with a lot of developers on the front line building AI systems, and they do a lot having to wrangle a bunch of system components, a bunch of different databases. And I have to come in there and tell them, look, you don't want to be doing all of this. This is an anti-pattern. Use one database. Like a human, you only have one brain. You don't have like 5 brains for different type of information you want to store. There's one brain. You probably need just one database that gives you all of this retrieval strategies. And that will be the Oracle AI database. But that's RAG, not too complicated to understand or even implement. But the key takeaway here is information today that your agents will encounter has this heterogeneous nature, and you need different ways to retrieve them and pass them to your agents. That's the key takeaway. So different form factors. Go on.
Richmond, I've been thinking a lot about this. One thing that we're trying to implement at Forward Future is I want to take all of our data sources. So whether that's like Slack messages, email, our videos and our video data, Asana, Notion, our internal notes, I want to throw them all into just a single kind of ocean of data and allow my agents not only to reactively, if I prompted, hey, answer this question about the data, fine. But I wanted to proactively look over that. Is like what you're describing potentially a solution to do that?
Yeah, for sure. Because the data that you're ingesting, it can be represented in different ways, right? You have a lot of data sources being ingested in centralized repository. What you need is a way to then surface up information. There are different ways you can surface up information. You can surface up information by semantics, which is meaning. You can surface up information by relationships, or you can surface up information by connections as well, one information to the other, which is where you start to have knowledge graphs. So there isn't just one way to surface information up. There are different ways. So having all of these techniques in one spot in one system can actually help you surface up information in the right way and put your AI infrastructure more consolidated and more efficient for your agent and for your developers to reason about.
Is this assuming I already have all my data in a database, or like it? Yeah. Like, go ahead. Yeah,
you can actually ingest data. This is not assuming you have all of your data. So you can definitely have all of your data in a database, but a database typically can have an ingestion pipeline, right? So there are connectors you can have to a database that will ingest this data. You can build a system that does it automatically from whatever sources you have. So if I go back to my diagram, I have this different data sources here, right? It's a representation of different data sources, and you just ingest that. You would have to maybe engineer an ingestion pipeline or use a third-party provider that helps consolidate this and then put that into a database like the Oracle AI database that will help you surface up intelligence with different retrieval mechanisms.
Okay.
So just to carry on, right? We're in this world of agents, and I'm going to move a bit fast. Agents have main components, which is the ability to reason, perceive the environment, use tools, and have memory. And once upon a time, I used to see definitions of agents that didn't include memory. And it was such an obvious thing to me that you need memory. But earlier definitions of when we were trying to define agents didn't include memory. So just moving on, we have things such as this agent loop, right? I'm sure people have heard about it, which is this ability for your agent to actually get in context, reason about the context, and decide about the next action. And then by observing, it could decide about the next action, maybe by calling tools, or maybe exiting the loop, right? This is what we call as the agent loop. And you can go through several iterations of this to build up the context and actually execute different action. And this paradigm is very powerful. But the key thing is, as your context window starts to grow, one thing we observed is we needed to actually engineer the information within the context window. So we had to think about the signal to noise ratio of information that we're putting into our context window. And Anthropic I've written a couple excellent blog pieces on context engineering. There's some that have come from folks like Cognition, LangChain, and a few folks have written a lot on context engineering and how to engineer information within the context window. So there's a few techniques, and I do go into them, but for the sake of time, I'll just talk about them at a very high level, which is one of it is context window utility. your LLM needs to actually be aware of its own limitation. And one of those limitations is its context window capacity. There is no way your LLM can manage its context window if it doesn't know the current utilization of it and its capacity. So when you're using Cloud Code, you probably see a percentage value of the how much context window it has left before it starts to actually auto compact, right? And that leads me to another context engineering technique, which is reduction or compaction of information within your context window, which most of these tools actually do. And that is just reducing the information in the context window so that you can actually continue to utilize the context window without actually exhausting it to its limits or causing a lot of issues like context bloat or context rot. So you have this auto compaction functionality within Cloud Code where Claude automatically compresses information within a context window, leaves a summary within it, and then you're able to continue on with some of the conversations that you're having. We talk about how you can implement this by yourself as well in some of the courses and some of the tools we release, because it's not that difficult to actually implement, but there is difficulty in making sure that you have a high signal representation in your summary that you've generated from your compressed information. And then there is context offloading and context retrieval. So I touch on all of this in several places on my social profiles or in courses I teach. But that's context engineering. Any questions on that, Matt? Do your audience have any questions?
I think I'm gonna bring Fox on the run back. He's saying it's all because like we need all of these workarounds because the models can't hold persistent state. I think that's very accurate, but they can't. And we have like I'm sure there are plenty of researchers working on continual learning. But we don't have that right now. And so all of these, and by the way, it feels like we're just scratching the surface on context engineering. And so there seems to be a lot of gains left just here. And maybe in the future, great, this won't be as relevant, but it is extremely relevant today. So I just wanted to address that.
There's still a lot of gains left. And one thing I would say is this. We need to look at things in terms of timelines and perspective, which is we're not the only architects of intelligence. And by we, I mean humans. Another architect of intelligence is nature. And nature has had billions of years to create the ideal form of intelligence, which obviously I'm biased, but it's human intelligence. But nature has had this experimentation over billions of years to get to where we are now. And us as humans, we're trying to do this in a compressed amount of time. In AI as a field has not existed for even 100 years. It's probably 70 years now. So we're trying to do all of this, I guess, comparison to our intelligence in a very short amount of time. And I would say we're not doing a bad job.
Yeah. So, Richmond, let me read this to you and you answer it. So Guy 15X, how should an agent decide what to forget, given that storing everything creates retrieval noise and cross-system drift?
Yes. So learning how to forget is where the creative part of agent memory comes in, because there is not one way to forget. And even to make it more complicated, we don't understand what goes on in the human brain fully. Neuroscience is still an active area of research. And neuroscience is still trying to understand how human memory works. And whether it's myth or legend, whether it's myth or fact, humans, the current thing that I've read from research is humans actually never forget information. Like everything you experience in your day-to-day is stored in your brain. The human brain just has a better way of surfacing it up, right? This is what I would say in a computational form. You can implement mechanism of forgetting by looking at factors that you can attach to memory units, such as recency, relevance, and importance, right? So when you can actually compute, these a weighted value of that is made up of several metrics, and then use that as a way to either surface up information or reduce the importance or the signal of other information within your system. And this is, again, is what the paper generative agents simulacra actually touches on. They implement a forgetting mechanism. And even that simple implementation can get you to a very good level of performance, which I will show as well on some of the charts and implementation that I'm going to share in a second.
Okay. One more. This is more of a comment, Guillermo.
Yeah.
I know this might be cliche, but this reminds me of all the infrastructure surrounding the CPU, L1, LN, cache, RAM, etc. Yeah, I mean, look, I'll just give a brief thought and then Richmond jump in. Karpathy kind of said it, right? This is the new architecture of computers. LLMs are the new operating system, and so if you think of it in that way, yeah, I think you're right, Guillermo. There are short-term memory, RAM, long-term memory, hard drive. The actual LLM is the CPU. So I think you're correct to draw that analogy.
Yeah, for sure. And it's the same analogy. I don't know who did it first, whether it was Andre Karpathy or maybe it was the MemGPT guys, but the same analogy is used in the MemGPT paper.
Yeah. Let me see. I think, let's keep going.
Okay, let's go. Let's keep cooking. So the thing is, a simple agent interaction that is kind of like one-dimensional, which is you ask the agent a question, the LLM reasons about it, and you get your answer back. It is good, but it's not going to get you far enough. And what I mean by that is, in most use cases that are actually important to developers or to even general society, you're going to be working on long horizon tasks. So you need to have a system that can manage its own context window and actually give you the impression of learning and adapting to new information. So software debugging, right? Coding is pretty much what everyone's focused on, and that can be a long horizon task. Research and synthesis reports generation can be long horizon. And all of this requires you to have agents that can have several iterations of the agent loop, and yet maintain its context windows capacity at a decent level and not lose any accuracy or increase latency. So agent memory is what the concept of agent memory is about. It's all about that. How do we make agents have this reliable sense of information adaptation and able to actually be reliable, capable, and believable? Yeah. So I'm going to go back to humans here. We have, I guess, a very good memory system and intelligence system that is based on memory as well. But there are different types of memory in humans.
Richmond, can I interrupt? I want to put something on screen. Hypersonic Monkey Brains. Great name. Put the LLM in charge of its own context window. And we kind of dabbled on this point earlier with OpenAI's feature. Like, should the human be in the loop saying thumbs up, thumbs down, this is good context or not? A lot of what you're describing is human curated context engineering. Is there a future in which the model itself can just manage its own context, or is that kind of, snake eating its own tail type thing?
I think there is. I think there is a future where we would have an agent that can actually refine its own harness, right? And optimize.
Oh yeah, did you see that paper from a few weeks ago?
Meta harness.
Meta harness, yeah.
There we go.
That's right.
Yeah, exactly. So it's obvious, right? It's still early. In terms of what, and someone just says, no, mine is doing that now. Someone in the comments. So I guess it's not as early as most people think. But this is where we're at, right? That is going to happen. I think 2026 is really focused around the scaffolding around LLMs. I think in the previous years, we've been focused on the LLM capabilities, but I think we've gotten what we can out of the reasoning capabilities of the LLMs. Now we're focusing on this system around it, and it's an important factor. And you can see it's important because OpenClaw is harness, right? And you have Manus has a very good harness around the LLM that allows it to do several tasks. And I know the acquisition by Meta got blocked, but those guys are cooking. They've been cooking.
Yeah.
So the system and the scaffolding around it and is very important. Having an agent that can actually refine that is an interesting paradigm that is definitely worth exploring.
Richmond, someone's calling out your Titan book. Can you talk about what that is?
Oh,
Behind
the
you.
Titan book. That's good. It's about Rockefeller. It's
Yeah.
about Rockefeller.
Yeah,
So
show that.
yeah.
Nice. Oh, I gotta
it's
read
it's
that.
a it's
That's
a
a
hefty book. It's a
yeah.
hefty book. Do you know what it is?
Yeah, good call. All right. Yeah, let's see. Raymond Blackwood working on self-healing harness. Yeah, I think there's a lot of work on that right now. Richmond, if you want to continue, please
Oh
do.
yeah. I stopped sharing, but let me get back to it. Let's do this, and you can pop it up. Let me know when we're good.
Yeah, we're it was good. Now it just says loading on the screen.
It's gonna come up in a second. There we go. We good?
Yeah.
Okay, so agent memory, right? And you can think of agent memory of this exocortex on top of the LLM that makes it remember and adapt. And there are different ways you can think of agent memory. And this is where we start to get more into agent memory. And you can think about it in terms of duration. Very easy, short term, long term. Whatever is in the context window is probably short term. Then when you start to put it within a file system or database, you go into this long term realm. And I've done a couple of blog posts on file system versus database as memory substrates. And we can talk about that as well. That was a debate that happened in the beginning of this year that I was involved in, whether you want to use file system or databases for your agent memory. But there's another special aspect of memory, which is coordination, which is more of a shared memory paradigm where you have multi-agent systems and you need to actually make sure they coordinate effectively. And then start to look at cognitive function is another way you can distinguish agent memory. And this is when you start to look at paradigms we have in humans have working memory, procedural, episodic, and semantic memory. And we can look at the computational forms of all of these cognitive functions. So an example of procedural memory is going to be something like skills. Skills.md files are very popular. Markdown files that describe how to do certain tasks for agents are very popular. But this is procedural memory because what you're describing to the agent is a step-by-step process on how to conduct a certain activity the way maybe you've conducted it previously. So skills.md files are basically SOP for agents, standard operating procedure documentations for agents, essentially. Another type of procedural memory would be things like a toolbox. So one paradigm I talk about a lot is actually storing your tools in a database and surfacing them up when you actually require them using some form of retrieval mechanism. And this is a way to scale the number of tools your agent has access to without, I guess, bloating the context window. And we talk about this as well in a couple of materials that we've done and in a couple of courses we teach. Episodic memory is an easy one to actually remember. Just think about conversations you're having with a chatbot, with an LLM, with an agent. The back and forth interaction is episodic memory because it has some form of time association with it. And there are other types of memory, semantic memory and shared memory. So that is agent memory. And on this slide is a lot of, in the early days, people used to ask me, Richmond, why do you keep referencing human memory? I guess because most people saw understanding things like a computational system, like the CPU parallel makes more sense. But I talk to a lot of non-technical people in my day job, and that requires me to sort of draw parallels to what people understand. And one thing that people understand is themselves, and that's why I use human memory as a way to bring people into agent memory in the computational form. And we've done this as a society, as a society that's trying to solve things using technology. So I'll go from left to right. David Hubble and Weisel were neuroscientists that experimented on the visual cortex of cats to understand how neurons in the brain reacted to visual images, right? They did this in the 70s. They won a Nobel Prize for this. But what they researched actually impacted and influenced some of the things that we did around convolutional neural networks, which was the dominant neural networks before transformers. And we used them in most of the face detection systems or pose estimation or body detection systems that we have in our mobile devices or other devices we have. So you see this borrowing from neuroscience happening into the field of machine learning and deep learning. And if you go into more mechanical engineering, the first inventors of flights or explorers of vehicles of flights were looked to birds and animals of flight, and they looked to birds that flap their wings. And that's why the first attempt at creating vehicles of flight had literal mechanisms where there was a flapping mechanism involved. So again, looking to nature, inspiring mechanical or computational engineering, and getting us ahead, or in a way that we could have not done without actually getting this inspiration. Now, planes move faster than birds today. So that is why I use the human analogy here and human parallel. It just helps. So memory, when you have your database, memory can be, you can have different memory types being represented as tables within your database, and it's still some of the same paradigms that we've used in RAG that we're bringing into this agent memory topic. So that was the context engineering, but now there is something we need to really think about. And I've been saying this for a number of years, so I coined the discipline of memory engineering. So if you actually follow me on LinkedIn, or you looked at my LinkedIn, I did something which was 100 days of agent memory. And where I was talking about agent memory every single day, and I was just sharing my learnings on LinkedIn and sometimes on X as well. But memory engineering is important. And you can see that this is what Anthropic and OpenAI are doing today, whether it's dreaming or whether it's taking human feedback. You need to engineer systems that can take information and actually either create new information from the existing information, or consolidate or forget or augment the memory itself. So this is different from engineering what's in the context window. Now you're engineering what's outside of it and even what's inside of it as well. So this is memory engineering. And then you have other aspects of systems that you need within your agent harness in a sense. So this can be looked at as an agent harness. And when you do all of this, and this is the interesting thing. But before I get into this, do we have any questions from your audience?
Yeah, not a question, but this is super interesting. Fox on the Run coming with the bangers. Hopefully Lienthal didn't copy feathers. He found the principle. Hubel Weisel showed continuous hierarchical processing. We took discrete tokens and called it intelligence, aka we're basically building feathered planes. Do you agree with that? Like, kind of, he's basically maybe giving his own version of the analogy.
Yeah. I need to copy and paste that and just like digest that onto the live stream.
No, the crux is like we didn't identify something and build it in our own way. We're basically just trying to say like, oh look, that's a bird. Let's make a big bird.
Yeah. And that, in fact, we're still building feather planes is a good way of saying it. And I think it's enough. It will get us where we need to get to if we actually apply the same paradigm to agent memory.
Yeah. Okay. All right. Yeah. You're still digesting it?
Yeah, I'm still digesting this.
Yeah, grab a screenshot of that message. Yeah. Fox on the Run. Very nice. Very nice.
Yeah. Am I still sharing my screen? Do we see like a graph on the screen?
Yeah.
Okay, nice. So look, the one thing about this is we don't just talk about this, right? We're in the arena, we're experimenting, we're putting stuff in Python packages, we're optimizing the database over our Oracle to make sure we're creating a system that our developers, our customers can rely on to build more production ready performant agents. Now, on the screen right here, in the red diagram, and all of the code, for those who are technical, all of the code that we're seeing is on the Oracle AI Developer Hub that I shared, that Matt shared earlier on the chat. So you see the code and you can experiment with this yourself. But on the red axis, on the red line, this is a naive agent. And what I mean by naive agent is it doesn't have any engineered memory. It's just basically appending each interaction to the next interaction for every iteration, right? So we're not engineering memory, we're not consolidating memory, we're not summarizing, we're not doing any of the fun stuff. But on the green axis, not on the green axis, on the green line, we have an engineered memory using the Oracle AI agent memory package. And as you can see, I ran this for 100 turns. This was like an interaction for back and forth. We went back and forth 100 times. And you can see the token consumption go up for the non-engineered agent, but you can see the token consumption for the engineered agent stay relatively stable. So in a sense, you can almost run this for, I don't know, maybe 1,000 iteration, and you would have infinite context in this rough way of using the word infinite context. I've not done it for 1,000 iteration, but maybe I'll do that. But this is just 100, and you can see it's stable. Now, people will ask me, hey, yes, you have lower token utilization within each iteration, but is it accurate? Can the agent actually remember? Well, in the notebook, one thing I did was actually implement an LLM as a judge, in where we use an LLM to actually gauge each of these responses to questions and see which one it prefers, right? And here we can see the LLM actually preferred the engineered memory rather than the naive one. And there were cases where it was a tie. So this is just using the LLM as a judge. So now we are maintaining token consumption, right? Keeping it efficient and still maintaining a sense of accuracy. Let's put a pause there. Any question? Let's digest this.
Not a ton of questions. We have a lot of comments though. Okay, I'll show a few. By the way, if you have comments, if you have questions, drop them. We'll talk about it right now. Huge reaction of those that are not technical. Just give it to Codex. Yeah, basically. And by the way, we'll put the GitHub link and everything in there. Let's see. Gareth Hood, your brain runs on 7 networks, default mode, executive, salience, 2 attention ones, sensory motor, and visual.
Yeah.
Okay.
Nice.
Yeah, that's about it. Let's keep going.
Yeah, let's keep going. Those are some good comments, and I think you have a different variety of folks on your audience, and this is very good. We'll keep cooking. So here we can see, obviously, we're maintaining accuracy, we're maintaining operational cost, and there are other things, right? Some of the more technical folks will probably think about, okay, this is great. You're maintaining operational cost by token consumption. You're also maintaining accuracy, but how about the KV cache? How about let me actually just scroll down to this graph. How about the KV cache, right? Which is, how about this implementation of, how about this mechanism of storing, or at least making the operational, of making the inference a bit faster, that the LLM Frontier Labs actually provide you. So OpenAI has automatic prompt caching, which is if you are actually maintaining the representation or the actual structure of the prompts that you're sending for inference, or whatever's your context window, to your inference provider, if you don't change it, they will actually store the computed attention for these and not have to recompute it, which is save on latency and actually save on operational costs as well from their end, right? That's KV cache. I see some people in on your audience know what I'm talking about. But yes, there is that. Yeah, it does seem like overnight everyone started talking about KV cache, to be fair. And Cognition, the folks at Cognition and Manus were early to talk about it, and they shared about the context engineering solutions that they were using to maintain KV cache. So I did an experiment in the same notebook, is where we have a naive end-to-end.
Where can people find
this notebook or
the notebook?
This note, yeah, for sure. In the Oracle AI Developer Hub is where the team is always cooking, and we're serving everything there. So let me put a link again to this particular notebook that I'm showing.
Yeah, drop it in our chat, and I'll put it in main chat.
So we are always cooking. So yeah, so exactly. So KV cache was something that came up, and of course. Sorry, go on.
Brian giving his great commentary in chat. Thanks, Brian.
So what we're seeing here is this, right? You have this naive end-to-end. A naive end-to-end model is actually a naive end-to-end memory implementation where you're just appending information to the context window and then serving it up, is actually going to maintain the KV cache on your frontier lab or model provider side, right? So you're going to see low latency in terms of end-to-end latency, in terms of what's going on the inference side, from retrieval to inference and getting your response back. That's what you see on the red, right? KV cache has been maintained. Then on the green, you have this optimized AI agent with all of the memory engineering technique, and you can see it's a bit higher in terms of latency. But on the blue is a happy middle, is this happy medium where you're using some of the actual implementation of memory engineering that we talk about, and you're actually able to maintain an end-to-end latency that is comparable to when you're maintaining KV cache. I'm going to do a blog on this very soon. I'm going to do a blog on this very soon when I come back in a few weeks, and we can talk more about this, right? This is where you go into memory engineering. This is where you start thinking of operational costs, where you start thinking about how can I do something beyond what the frontier labs are doing and build my own system, because everyone's building their own harness today, right? Everyone's building their own knowledge bases after the tweet from Andre, right? Everyone started building their own knowledge bases. And I think everyone is going to have their own bespoke harness.
Really? I mean, when you say everybody, you mean like everybody, but within like a very narrow group of people, right?
So this is what I would say. I think, and this is what we're seeing, right? The barrier to entry with software engineering, and I use that term very loosely today. The barrier to entry to software engineering is lower than ever.
Yeah.
Right?
I mean, we literally had a comment earlier that was like, for those who don't understand, just give it to Codex.
Just give it to Codex. Exactly. So you can give Codex, a blog post and just say, can you re-implement everything that is being said in the blog post and use it for me to be able to do a certain task or for my specific workflow? And this is why it's important, because memory, or the implementation of memory, can differ depending on workflow, or what I call application mode, right? There are three main types of application mode we're seeing: deep research, assistant, and workflow, right? So deep research is when you're going deep on like a particular topic and you're scrounging the internet for different sources of information, and you're creating, the end result is an extended amount of reports back to the end user. Then an assistant is a back and forth conversational agent. But I think you have a question.
Yeah, so let's do this, Richmond. If there's any more questions, drop them in chat right now. Let's try to answer them. I think Guy I5X has a really good one. I'm going to read that off. You could start getting that and then answer it, and then we can close out this section.
Let's do that.
Okay, so Guy I5X: does pre-filling the KV cache with consolidated memory embeddings at session start meaningfully reduce retrieval misses compared to on-demand loading. Now, before you answer this, Richmond, for those of us, including myself, who maybe understand 3 of the words in this question, break it down. What is he asking? And then please answer.
Does pre-filling the KV cache with consolidated memory embeddings at the session start meaningfully reduces retrieval misses compared to on-demand loading? This is reminding me. Okay, so let me break it down. So pre-filling the KV cache with consolidated memory embeddings. So what that is saying is when you've consolidated memory, these are information that you. Let me use it in what we can actually understand today. Okay, so you know the way Anthropic has this dreaming feature now implemented. Now they don't have the model doesn't have to actually determine which information does it need to prioritize within its own reasoning logic. Now this consolidation has solved it. So you pre-fill that into, you generate embeddings of it and pre-fill that and put that into the context window. And so you avoid the pre-computation of that. And there is a paper called CAG, that came out last year that spoke about actually computing the KV cache and actually just putting that into the context window so you don't actually have to re-implement that. And I'll get the paper up and I can share this. But the answer to the question is, I don't know. I'm going to need to experiment with this. Let me do that. I'm just going to get the paper for CAG. It was called Cache Augmented Generation, and I think this is what this person is referring to. And yes, I've got the paper. And that paper came out in 2024. And I'm just going to share that with you, Matt, and you can share that with the audience.
Okay, I'm putting it up.
Right. So that paper was basically you pre-compute the KV cache, so you'd have to do the pre-computation on the end of the inference provider, and then you save on all of the operational costs in another, and you can avoid doing RAG as well. Was this paper's argument? But I haven't seen an uptake of this. I've not seen this being implemented, so maybe I can revisit it and do an implementation of this.
All right. So final thoughts, Richmond?
Okay, let's go. Final thoughts. I'm going to stop sharing. This is my final thoughts. Everyone is so heads down in 2026, focusing on the harness, right? And I think it's important, and this is an important thing, which is everyone can now participate. Everyone can participate in what's going on in the space today, and agent memory gives you that entry point into having your way of doing things in terms of your creative mechanism of how you think memory should be implemented. And you can compete with some of the frontier labs on the memory implementation, or at the very least understand what's going on. So my final thought is, there are several materials that I've provided you and me and Matt have provided you in this conversation. Check them out. Hit me up on LinkedIn. Hit me up on X, and we are just going to be in the arena, and we're going to be sharing more information with our audience. Check out the Oracle Agent Memory package and implement it in your system, and then give us feedback. Give me feedback, and we will reflect that either in the Oracle database itself or in the package as well. So we're listening to developers, and I think there's an echo.
Is there? Oh, there's an echo all of a sudden. Okay. I see. Boom. I got it. Okay. Sorry about that, everybody. I'm still figuring out how to use things. I actually just dropped that deep learning link once again, featuring Richmond, Andrew Ning. So go check that out. It is free if you want a really great deep dive on agent memory. That's where to get it. I just dropped it in chat, so go check it out. And yeah, sorry about the echo, everybody. Richmond, I really appreciate you coming on, sharing all your knowledge with us. Please come back again. Yeah, we'll have to bring you back on soon.
All right. Thanks a lot for having me, and thanks a lot for the good questions, guys.
All right. See you, Richmond. All right. I think we're going to call it there for today. I meant to play around with GPT voice, the new one. I just don't know much about it yet, so I have to actually go test it. So I'll go test it. Maybe we'll stream again tomorrow once I have had a chance to really check it out. So until then, see y'all later. Go check out forwardfuture.ai. Follow us. Follow me. All the channels. We're everywhere. Twitter, YouTube, Instagram, TikTok, Twitch, all of them. Hope you enjoyed. See you later.